So with rationalizing the denominator, what it means is before, when you're looking at problems, we were able to simplify it down to where we always had a perfect square for the denominator, right? We had square root of 25 for the denominator, square root of 49 for the denominator, square root of 81 for the denominator. Those were all perfect squares. But what happens if you can't simplify and you're left with a value that is not a perfect square for your denominator? Okay, we cannot simplify 5 over 12, and 12 is not a perfect square. So in order to rationalize the denominator, what you wind up doing is multiplying. You're going to multiply both the numerator and the denominator by whatever your denominator's value is. So I'm going to multiply by the square root of 12 on the top and on the bottom. Okay, so what this looks like is me multiplying 5 times 12 for the top, and then 12 times 12 for the denominator. That gives me the square root of 60 over the square root of 144. We've now created a perfect square, right? Square root of 144 is a perfect square. Let's go ahead and break 60 up. 60 also has a perfect square inside of it. It happens to be a 4. So we can get square root of 4, and then we're left with the square root of 15. What is the square root of 4? 2. So we have 2 square root of 15 over, what's the square root of 144? 12. Okay, so now I've taken all my square roots that I can. I'm left with this value. Is this a final answer? Yes or no? Those of you who said no, why is this not a final answer? What else can I still do? Divya? I can still simplify the fraction. If you take a note, the 2 and the 12, they're both in pink, so it's almost as if I could just say, hey, this is a fraction 2 over 12. They both happen to be divisible by 2. So I'm going to divide them both by 2. 2 divided by 2 just gives me a 1. So that would be 1 square root of 15, or just square root of 15. And then 12 divided by 2 gives me 6. There's my final answer. Square root of 15 over 6. Yes? Without the square root, essentially, right? That's what I'm showing you is longhand what you're doing, but what Alex just said, he says, so essentially you're just multiplying the numerator and the denominator together, and then just keep the numerator as it is, but without the square root. So yes, it's going to be the same, the denominator stays the same, but the square root has left. You are just getting rid of the radical sign. When you take the rationalizing of the denominator, it removes the radical sign. Okay, let's try number 2. We have square root of 7 over 2. Again, this is not a perfect square, so we're going to go ahead and rationalize the denominator. We're going to multiply both the numerator and the denominator by the square root of 2. Okay, so I'm just going to show you what it looks like longhand again, and then eventually we'll simplify it down to where we don't have to do that. So we're going to multiply 7 times 2, which gives us 14. Then we're going to multiply square root of 2 times 2. When we do 2 times 2, that gives us 4, which happens to be a perfect square. Now we can go ahead and solve it. Can square root of 14 be broken down? No. Square root of 14 cannot be broken down into any perfect square, so it stays square root of 14. Square root of 4 just simplifies to a 2, and that's it. We're done. Go ahead and do one more. We're going to do problem 3. Okay, so for problem 3, we have 2 square root of 80 over the square root of 7. Again, the square root of 7 cannot be simplified with anything inside of the 80, so therefore we're going to rationalize our denominator. We're going to multiply both the numerator and the denominator by the square root of 7. Okay, now that 2 is not going to get affected at all. That 2 is a coefficient that's on the outside of my square root. What is going to get affected is I'm multiplying 80 times 7 on the inside, and then I'm multiplying 7 times 7 for my denominator. Okay, so this now becomes 2 square root of 560 over the perfect square of 49. Okay, before I start taking square roots, let's see if we can break 560 up. Is there a perfect square that we can break 560 up into? Actually, we're running out of time. Let me just tell you what it is. Square root of 16. Square root of 16 can go into 560, and it can go into it 35 times. So we have square root of 16 and square root of 35. We still have that 2 on the outside. All of this is over square root of 49. Okay, when I take the square root of 16, that gives me a 4. So I now have 2 times 4 on the outside and square root of 35. All of it over square root of 49, which is 7. Now the 2 times 4, that's going to come out to an 8. So I get 8 square root of 35 over 7. And that's my final answer. Okay, I'm going to post a quick quizzes for you to do tonight. That's just rationalizing the denominator with numbers only. And I'm going to throw in a couple of quotients of radicals from yesterday. I'm going to throw a couple of those in there. It'll be 10 questions only. It needs to be finished before class tomorrow.